Hey everybody, today we're going to be learning from Chapter 7, Lesson 2. We're going to be learning about addition equations. So yesterday we learned from Lesson 1, we learned what an equation is. We learned it's an expression with an equal sign and another expression. Today we're going to be building on that and learning about addition equations. And first we're going to kind of show what an equation looks like with a scale, because we always want to keep that equation balanced, okay? So if you think about it, an equation has an equal sign between both expressions, right? Yesterday we saw an expression, an equal sign, and an expression. So we want to keep that balanced because it is equal. So let's start. And also, please follow the process that we're going to do here. I know a lot of you may have shortcuts or you know how to do things in your head, but you really want to learn to follow the process. Okay, some of the things we may be doing here may be really simple, but later on in math, it's going to get a lot more complicated, and we want to be able to follow that same process. Okay. All right, so an equation is like a scale, okay? And we're going to draw that scale here. So imagine that we had some scale looking like this. And right now the scale is balanced, right? It's even, okay? But if we added something on this side, it might tilt, and if we added something on that side, it might tilt, okay? We want to keep it balanced though. So that's our goal throughout equations. So on our scale today, we have 5 counters on this side, and counters, they're just like weights. Okay, so we have 5 weights on this side, and on this side we have a cup and 3 counters. Okay, so in this cup we don't know how much it weighs. We don't know how many counters are in it. Okay, so because we don't know, we're going to say that this cup is our variable x, okay? Because, you know, it's an unknown. And remember, that's what a variable is. It stands for an unknown number. Okay, hopefully you can see a little better. So right now we have 5 counters on this side, an unknown amount in this cup, and 3 counters. But if you notice, our scale, it's still balanced. So that means this equation is equal. Okay, so now let's rewrite what we have shown here. So we have 5 counters on this side, which is equal to x plus 3 counters. Okay, so we have 5 equals x plus 3. Now, a lot of you may know what x is. You can probably do this in your head. You can do this mentally. You're thinking, this is obviously balanced. So for it to be balanced, for it to be equal, I know what x is. But hold that thought, because remember, we need to follow our process. Okay, so before we move on with this, we've got to learn 2 things to help us with our process. So the first is going to be the subtraction property of equality. Okay, so subtraction property of equality means you can subtract the same amount from both sides. Okay, so subtraction property of equality means you can subtract the same amount from both sides. What that tells us is if we look at our scale, right now it's balanced, okay, but if we were to take one counter away from this side, and if we were to take one counter away from that side, it would still be balanced. So what it's saying is, if we take one away from this side, we have to take one away from that side to make sure that it's still equal and balanced, okay? That's why it's called subtraction property of equality. So that's really important to keep both sides of our equation equal and balanced. So whatever we do to one side, we have to do to the other side of the equation. Okay, and then so let's just make some bullet points here. So scale stays balanced, and if the scale stays balanced, then our equation stays balanced. Okay, now the other thing that we're going to learn that's going to help us in our process to keeping our equations balanced is inverse operations. So inverse operations, they are operations that undo each other. Okay, a lot of students think of this as the opposite of something, but it's called inverse, the inverse of it, okay? So it's okay to think of it as the opposite, but it's really called the inverse operations, and then it undoes each other. So let's write that down. Operations that undo each other. Okay, so if we think of addition, okay, subtraction undoes addition. And if we think of subtraction, the inverse operation to subtraction is addition. And think of multiplication. The inverse operation of multiplication that undoes multiplication is division. And if you think of division, the inverse operation of division, the operation that undoes it, is multiplication. Okay? So that's something we should highlight. Those are all the inverse operations. Okay? So if you're ever confused, you can always look back to your notes and kind of see what the inverse operation for multiplication, division, subtraction, or addition is. Okay, so now that we've learned a couple properties or inverse operations, we can now use that to help us in keeping an equation balanced. Okay, so let's solve addition equations. Okay, so again, that was our ultimate goal, right? Our goal today was to learn about addition equations and keeping them balanced. And we're going to solve some addition equations using this process we just learned. So let's go back to our original addition equation that we had up there. So we had 5 equals x plus 3. Okay, and again, you can probably think of this in your head. You probably know what x is, and that's okay. You can think of it mentally, right? You know it needs to be balanced, so you probably know what x is to keep the equation balanced. But we are going to follow our process. So subtraction property of equality. We are going to use this to help us keep this equation balanced and find what x is. Because this is our goal, to find out what x is so we know what keeps this equation balanced. Okay, so one thing I do to make sure that I'm doing the same thing on both sides, because that's what we talked about here. Whatever we do to one side, we have to do to the other side. So in order to do this, I sometimes like to draw a little line. It can be with a highlighter, it can be with pencil, whatever you want to use. But this line is like a mirror to me, okay? So whatever I do to this side, I have to see on the other side. Whatever I do to this side, I need to see the same thing on the other side. Okay, so this helps me remember to do the same thing on both sides. So I am going to find out what x is, I need to take 3 away from this side. Because I just want to find out what x is. So if I take 3 away, then I'll get x by itself. Okay, so I'm also going to do the same thing on this side. This line tells me I have to mirror whatever I do on this side over here. So I also need to subtract 3 right there. Now I'm just going to look at this side of the equation. Okay, I'm going to subtract 3. When I'm subtracting 3 though, I'm just taking 3 away from this. So 3 minus 3 is 0, and then nothing happens to our x. So we're just going to drop the x down, and again 3 minus 3 is just 0, so you don't need to write anything. Now I'm going to look at this side. 5 minus 3 is 2, and again I'm going to remember my equal sign. Okay, so x equals 2. We kept our equation balanced by removing 3 from this side and removing 3 from this side. Essentially, we took those 3 counters away, and we also took 3 counters away over here. So that means that this cup right here is equal to 2 counters right here. Okay? So that's what we did, took 3 away, x equals 2. That's our solution. So now that we've found our solution, okay, we've solved an addition equation, we are going to check our solution. We're going to check our work, make sure we got it right. And remember, I know you can do this on your own, but following the process is important. This is a very simple equation, but in your textbook, or maybe even next year in math, it's going to get a little more complicated. Okay, so we are going to check your solution. First thing to do when checking your solution is going to be to write down the original equation. So our original equation was 5 equals x plus 3. And now after we've written our original equation, we are going to replace the variable with the solution. Okay, so here's our variable, and we know that our variable equals 2. So we are going to replace our variable here with the solution. So 5 equals 2 plus 3. Right away you can probably tell that's balanced, right? We have a balanced equation here. I'm going to solve it just because I'm following the process. 5 equals 5. So I know that my equation is balanced. I've kept it balanced the entire time, and that is the goal here, okay? You can't do something to one side of the equation and not do it to the other, okay? You have to do the same thing on both sides of the equation. That's it for today, okay? Make sure you're following this process. Use inverse operations, okay? Here I had x plus 3. In order to undo this, I needed to subtract 3, right? I was using the inverse operation, okay? Inverse operation for addition is subtraction. That's why I use subtraction here, okay? If you have any questions, let me know in class, and we will be doing a couple class examples.